Okay, final part of the Igneous Rocks lectures is how do we classify these guys? As you know, I'm going to ask you to classify some igneous rocks. In fact, we'll be doing that, well, I can say tomorrow since I'm recording this on Monday night now, but Tuesday in lab, so maybe when you are hearing this, the same day. So we want to be able to classify igneous rocks based on all the stuff we now know about how they form, and what they look like, and what their chemistries probably are. So, first or second slide back in the first lecture, I told you that this intrusive and extrusive idea was going to be very important in the way we look at all the igneous stuff, including classifying the rocks. And so we spent some time on the intrusive versus the extrusive, and now we're going to use those same ideas to classify the rocks. And I kind of gave you a preview here with this piece of granite and this piece of rhyolite with exactly the same chemistries, and the difference being intrusive and extrusive. And we'll use those two different things to make a two-dimensional, like a grid type classification. So the chemistry that we're looking at in that last slide would be that it is granitic chemistry. It's felsic. Okay, fine. Then we look at the texture, and so the granite, the one on the top in the previous slide, had a coarse phaneritic texture. So we're going to classify it as a granite. Same chemistry, but a fine aphanitic texture, and we'll classify it as a rhyolite. So we're going to go through that grid and the way it works for all the different chemistries. First step, is my rock aphanitic or phaneritic? So what we're looking for here is basically an aphanitic rock, the mineral grains, and I know we're limited here in having to do everything via distance learning, so you can't pick up this rock and really look at it, but I would be doing this with the actual rock, and I would actually use my hand lens, a little handheld magnifying glass, and I would look even with it. Can I distinguish individual crystal grains? And if I can do so even with the aid of a handheld microscope, then it would not qualify as aphanitic. But in the case of this sample on the screen right here, even with that microscope, I can't see the individual grains. I can't distinguish them or do anything with them. It's just a mass of, you can see that it's grain E, but I can't make out the individual grains. Okay, well, if I cannot do so without a microscope, then I have to call this an aphanitic texture. Aphanitic. And it was what type of igneous rock? Apparently extrusive igneous. Aphanitic and extrusive go together. Cooled very quickly, and the crystals didn't have time to flow. Didn't have time to form. Okay, so contrast that. Exact same chemistry again. So contrast that to this one. Well, can I see? I don't even need my magnifying glass here. There's a quarter for scale, and you can see those pink grains. Those are potassium feldspars. The white grains are probably plagioclase feldspars. You got black grains in here, which are the biotites, and they're a little harder to see the gray in there, but those are quartz crystals. So yep, I can see crystals for sure here. So that guy is phaneritic, meaning that I can see them. Okay, but over here on the right, I've got an uh-oh case. What do we have? What do we have going on? Well, yeah, okay, I can see some crystals. Oh, okay, good. But wait a minute. Maybe most of the rock, it looks more like this guy where I can't see. Okay, so this is one of those places where we are going to have to talk about an in-between version. And it can be that you can see some of the crystals, but then most of the rock is this aphanitic texture. And we'll call that porphyritic, which is kind of a aphanitic but has some big crystals in it. So porphyritic is our in-between sort of on that. Okay, and you know that the chemistry is going to be important with these. These are different mineral assemblages. I'm going to explain how this diagram works. I want to point out up top, this says volcanic. I could just as easily have said aphanitic, right? So aphanitic versus phaneritic. Phaneritic is plutonic, as we talked about in the last lecture. So any chemistry, pick any spot on here, and it can have either a phaneritic version or an aphanitic version. Okay, so we'll talk about those different chemistries. And I'll give you an example in a minute, but basically you look for it. Now these percentages, by the way, are guidelines. They're not, so every gabbro is not going to have this much pyroxene and slight bit of olivine and some small amount of plagioclase. That's not, it's much more flexible than that, okay? So a lot of gabbros don't have any olivine in them at all. Pyroxenes and amphiboles kind of fight each other during crystallization, so you don't usually get both of them together, but this implies you can get some of both. Biotite might or might not be there. Muscovite also might or might not be there. The plagioclases can really become mixed up. Quartz, now quartz is an interesting one because, as you see, there's a fairly even amount here of quartz in most of the granites and even the granodiorites, which are kind of an in-between flavor. But if you lose your quartz entirely, this one is kind of solid point. If you lose your quartz entirely, then you're talking about an andesite or a diorite. So that one does matter right here, that you don't have quartz. And then, of course, your potassium feldspars here. Even in a clear granite that we're going to look at in a minute, the potassium feldspars can be a little iffy on it. And potassium feldspars we think of as the pink ones, but they're not always. Sometimes you can have some sodium character to them that causes them to be a whiter color than the typical pink. But what I think of with a granite is usually it has the big pink potassium feldspars. It's got quartz. It probably has one or both kinds of mica, muscovite, biotite. It's definitely got some plagioclase. Has to have that quartz in it. And I'm a little surprised. The amphiboles, I think, are a lot of times missing from a granite. So I'm a little surprised at that end of the diagram. I might have brought it down to 0 at the end. But you know, I'm not going to take your minerals apart. I mean, this was done to me when I was doing upper level classes. But with your class, I'm not going to take this apart and dissect it, whether or not it technically qualifies as a granite or not. I want you to use your skills at the appropriate level that we're talking about here. And so let's look at this simpler classification than with all that chemistry on there. Now, we've talked about felsic versus mafic before, right? And so the terms, I know the terms keep getting mixed up here, but the mafic or basaltic, these guys are over here, the dark stuff. And then rhyolitic, granitic, felsic, those guys could all be synonyms for each other. They're the light colored stuff over here on the left. And I know this has a lot of white in it, but it's also got a lot of dark in it. And so this is our in-between flavor here with the andesites, intermediate flavor. Okay, so you see that I've got kind of a grid system going on here. And I've got felsic on the left, mafic on the right, intermediate in the middle. So that's my chemistry. And then aphanitic or extrusive rocks on the top. Aphanitic being too small to see the crystals, versus phaneritic, intrusive type on the bottom, or plutonic, you could call it either way, where I can work with the individual minerals. Gabbros are interesting because that's a mineral. See that cleavage face right there? That is an individual mineral, and you can see some here on the side, probably some pyroxenes or amphiboles here on the side. And so the gabbros are, you have to look a little harder because it's all dark stuff, but the minerals are there. All right, so that's our simple 2x3 classification. And so from the way I said simple classification there, you can guess that I'm about to make it more complicated. So let's talk about how this might not be enough, and we might need to take it a step further to try to classify some of our rocks. I basically zoomed that one down and made myself some room. So this is our same 2x3 that we just looked at. and then we're going to stick some other things off to the side and in between. We already talked about porphyritic. Okay, so that's one of our complicating factors. Is we could have, well, is it aphanitic or is it phaneritic? Well, it's aphanitic with phaneritic bits. Okay, so porphyritic could be in there to complicate things. All right, that's one thing. There's another one. So aphanitic, you cannot see the crystals. And phaneritic are big crystals. Well, there's another version down here that says, oh my, really huge crystals. And that's called pegmatitic or pegmatites. So look at this image. I mean, so that whole black zone is a zone of black biotite crystallization. And then right here in the middle, you can see that's one giant plagioclase, white plagioclase mineral right there. To give you scale, that's a rock hammer. So that hammer right there, let's see, that looks like a 3-pound hammer, so it is probably more than 12 inches long there. So these crystals are more than 4 inches long, so they're giant-sized crystals. So giant size is pegmatite or pegmatitic texture. Okay. Let's see, what else have we done? Oh, I think I've got another picture of pegmatite here. Yeah, I do. This one does have a scale in here. Over here on the right is a pen, like a writing pen. And so you can tell that those are really, really big crystals in there, even though now we're in a darker phase with a, they called this a gabbro, and I'm kind of surprised that they would call this a gabbro. I guess these are calcium plagioclases with the white. I would have probably called it a diorite, this in between one here, diorite pegmatite, but they've probably done more chemistry on it than I'm going to do, so I think I'm going to believe them with the gabbro. But a lot of this has to do with more chemistry than we can get to in this class to do. Okay, so another thing we talked about when we talked about the magmas earlier on, we talked about felsic, intermediate, and mafic, but we didn't stop there. We had one further with an ultramafic, right? And so back when we were doing the nesosilicate minerals, we talked about olivine being an ultramafic nesosilicate mineral. So you can have a rock entirely made of olivine, and sometimes it's called olivine as a rock. Sometimes it's called dunite. And so that is an ultramafic. And you see how I've kind of made my table smaller, my old 2x3 table, so I could shove the thing in between, and I could put these pegmatites down here off even bigger. And now I'm going to be putting ultramafic off far to the right here. And I forgot to put on my table, so I'm going to add it here. So we have pegmatitic, which is our really, really super huge. Phaneritic, which is just big. Aphanitic, which is small, too small to see without a microscope. And then let's put up here, let's put, see if you can read my writing here if I do it with a mouse. Let's put glass. So what do I mean by glass? So it's not minerals because they didn't technically crystallize into a mineral. And so I need to find you a picture of it. I'll make sure and show it to you in lab. But you've seen, I'm sure, before, obsidian. Obsidian is a glass. Let's see if I spell it right here. I don't have spell checker trying to write with my mouse. Obsidian is a volcanic glass. And so if we take this, we've got giant-sized crystals. So let's see. Aphanitic, I'm going to put down just little dots. Those are my crystals. Microscopic. Can't really see it. And then phaneritic, I've got my crystals here, right? So that's I'm trying to draw a crystal there, right? So that's my crystal. And then pegmatitic, just to give you this scale here, pegmatitic are huge crystals, right? Huge pegmatite crystals. So, and then my glassy minerals up here are just a solid, uncrystallized mass. Nothing separate about them. True glass. Okay, so hopefully our classification is plenty complicated at this point, and we can definitely talk through that more in lab as we try to talk about how to classify these guys. Well, let's try an example. All right, so this sample right here is a little small chunk from Stone Mountain in Georgia. Okay, so let's look at what we have here. Now let's see, the arrow that they already have labeled here is pointing to, actually, reading the paper, they're talking about polonium halos, so they're actually pointing to one of the plagioclases here. I want to start with the black minerals here that I circled. All right, what do you think those might be? Well, it's hard to see in the sample, but these guys are one cleavage plane. You can get in there with a small bladed knife, and you can pick little pieces of these out, and you'll see that they're little flakes. Flakes. Let's see. Flakes are like mica, biotite mica. Okay, so we've got some biotite mica in there. All right. Now there are silvery versions of the same flakes. Here's some. Here's some. Right in this area. You can probably see some here. Okay, those are the other kind of mica. Those are muscovite micas. All right, we got both of these. So, muscovite mica kind of ends over here. Doesn't go. So maybe we're on the left side of the diagram already. Biotite wouldn't limit us as much, but muscovite probably does. Okay, let's look for quartz. Now, quartz in this is not the white. Quartz is the gray minerals here. Those are quartz, but we definitely have them. So quartz, check. All right. Well, we're definitely on the left side of the diagram at this point. Okay. The white are my plagioclase minerals. Well, that didn't help us very much. And then turns out that there is another kind of gray-white mineral in here that's a little hard to distinguish, and it's that other version of orthoclase without as much potassium in it that I was talking about. And so we're over here on the far left side of the diagram. Now I got to ask, wait a minute. We were looking at a lot of different individual minerals. Well, if we're seeing individual minerals, it's not a rhyolite, because a rhyolite we wouldn't be able to see them. It must be a granite. So I would indeed call this a granite, even though the pink orthoclase might be hard to find in this. I'm still going to call this a granite. All right, and I'm going to redo this exact same mineral, this exact same rock example on the next slide with that simpler classification system we talked about. Okay, let's try it with this one. Here's my rock again. And we already know now, but I just want to walk through how I would classify it on this table. I've drawn a nice big blue dividing line for aphanitic versus phaneritic. So let's start with that. These big crystals or not? And I would say definitely yes. So that gets us down to the phaneritic side, right? Okay, so we're phaneritic. Let's see, what else should we be asking? Oh, was this one of those in between porphyritic things? And I'm going to say no, because all those different minerals that I picked out, I could pretty much make out lots of different kinds, not just one kind. So I'm going to call this phaneritic and not porphyritic. What else could I look at? What else could I ask about this? Oh, and I've hidden it with my mineral here. There was a even bigger version down here off the bottom of my screen, right? Are these giant-sized crystals? No, not really. Although, it depends on where you look at Stone Mountain, and you can find some tourmaline pegmatites, really pretty tourmalines, at Stone Mountain that are pegmatites. But this sample right here, I'm going to say no, not pegmatitic, because these aren't really giant crystals. They're big enough to see easily, but they're not giant. So I'm just going to stay with simple phaneritic. Oh, I had a picture to go with that, right? Okay, it's not that. Oh, ultramafic? Okay, no. This is not these darker than dark and getting green. It's not ultramafic, so we don't have to worry about those guys over there. But other samples you might. So not that. It's not a glass, right? Because we've got good minerals. Okay, so I'm going to end up. Oh, and we didn't talk about chemistry. So felsic, intermediate, or mafic. Well, I hope that you would not see this as mafic. It's too light colored for that. Now, if I handed you this hand sample in a regular lab class, and you ended up classifying this intermediate instead of felsic. I think I could forgive that. It's got some biotites in there. I mean, the right answer would be that this is felsic, just by the mass of minerals. But those biotites, they take up so much eye space when you're looking at it. You see the black minerals sticking out. So I could see how you could accidentally get it over here. But the best place to put it is a truly felsic mineral, and so I truly felsic rock. I'm sorry. And so if we have a phaneritic felsic, then that classifies as a granite. Same place. All right, so we'll get more practice in lab. See you then. And next we get to move to sedimentary rocks, which are actually my favorite.